Hello, my dear student. I'm Rakesh Chaube from Sunbeam Sun City. Jai Hind you all, my dear. My dear, in my last video, I uploaded the video on 7 fundamental quantity or 7 base quantity, along with the rules for writing the symbols and all that. Now, my dear, I told you on that day, besides this 7 fundamental quantity, there are 2 additional quantities, and that 2 additional quantities are called supplementary quantities. Right? So today, my dear, I am uploading this video only on supplementary quantities, and the question on that is name 2 supplementary quantities, give their units and explain in brief. Now, my dear, let's begin with the first supplementary quantity, and you have you have the awareness of this particular supplementary quantity, and that is plane angle. Now, my dear, when I talk about a plane angle, say I have taken a circular plane, because this is a plane, you can see this is one plane, right? So I have taken a circular plane, and this is the center of the circular plane. Okay. Now, my dear, my question is angle, that is plane angle. I have taken the arc on this circular plane. This is the arc. Let the name of the arc is AB. So if I draw the line from O to A, it becomes radius R. Similarly, if I draw a line from O to B, it also becomes radius R. Now, my dear, you can see there is an angle subtended or made at the center of this circle here. You can see. Similarly, my dear, if I take this arc, again there will be an angle made at the center like this. Similarly, I can draw this way. Everywhere I am drawing the arc. You can see. And so on. So, my dear, what is the observation here? You can see this is the arc. And let I assume the length of an arc AB is, say I have taken ds. Why I have taken length of an arc AB as ds, my dear? Because the arc is very small, right? You can see that this is the circle, and I have taken only this much arc, that is this much arc of the circle. Here I told that there are many arc I can draw, but here I have taken the arc AB, which is small in length, right? Suppose if I rub this, I rub this, and I got here an angle with an arc only, right? So this is length of an arc, and I have taken that length of an arc as ds. I said why I have taken d, because it is a small length of an arc. Circle is so much, I have taken small, I have selected small length of an arc, and here it make an angle, and that angle is also small. It is denoted by d theta. Generally, my angle is denoted by theta, any angle. But since the length of an arc is small, arc का length छोटा है, तो angle subtended at the center will also be small. If arc length will be big, like this, if I take in the center here, and here if I made one, and here if I made other, this is say A and this is B. Now the length of the arc is so much. So angle is also increasing, you can see. So here I try my level best to show you that as the length of an arc increases, right, the angle subtended at the center also increases. Okay, my dear. So ultimately try to understand why we have denoted. So here the plane angle in your NCERT book also it is denoted by d theta, not theta, denoted by d theta. The reason is that we are measuring a small angle in physics, my dear, and that small angle here, this is made at the center because the arc length is small. If arc length is bigger, if length of an arc will big, then definitely that arc will make the angle or subtend the angle at the center will also bigger in size, right? So take care of this part. So what is the length of an arc here? The length of an arc is nothing but ds. So here it is. Generally plane angle is defined as d theta is nothing but ds divided by r. Now what is ds, my dear? ds is nothing but it is length of an arc, and r is nothing but length of radius. I hope it is clear. Okay, so while writing this, thus plane angle is defined as the ratio of, because whenever we write numerator and denominator, my dear, when we are comparing here the arc with radius, right? So we have a numerator. In the numerator we have arc length, and in denominator we have radius length. So while writing this in definition form, you write it is a ratio of length of an arc to the length of radius. Length of an arc denoted by ds, length of radius denoted by r. Formula will become d theta is equal to ds by r. So simple. So it's very simple concept, my dear. Sir, if the arc cover a long length, angle subtended at the center will be large. If the arc cover is small length, angle subtended will be small. Here I have covered the large length. You can say the length covered here by an arc is more as compared to figure 1. You can see figure 1 and figure 2. Here length of an arc is so much, and here see the length of an arc I little increase. You observe that the angle at the center is also increased. So nice. If ds increases, arc length increase, d theta also increase at the center. Okay. Now my dear, there is question. Next question is, what is unit of this plane angle? Unit. My dear, the unit is radian, and the symbol of the radian is RAD, right? But when writing in the value, we write the radian as a symbol. You can write here as a small c also. Radian. Small c also is a symbol. Here I wanted to make a note of one thing. So here I concluded that plane angle is nothing but the length of an arc divided by length of radius. Or length, it is a ratio of length of an arc. This is the length of an arc, and this is the length of the radius. So it is ds divided by r, and this angle is subtended at the center of the plane body which I have taken. Here plane body I have taken, circular plane. So the angle subtended at the center. Okay. Another concept is that why I have written d theta, because the d theta stands for small angle. How I came to know that the angle is small? As long as the arc length is small, because for arc length also I have written ds, right? So if ds means what? D if I have written means it is small length. Physics में जब भी d लिखते हैं तो that is for small. So here length of an arc is also small, angle subtended is also small. Okay. Now my dear, next part is, this is unit is radian, and this is denoted by RAD, and that is also you can put it the symbol as C. Now here one point I suppose to make a note of this. In physics, my dear, whenever we got a numericals with the angle, right? My dear, it's our rule that whenever it is given degree, we are converting that degree in radian. Take care. For example, you all know that since 180 degree is equal to 1 pi radian. See, I am writing radian here in this way. Here degree symbol, and here I have written radian symbol. You can see like this. Okay, so 180 degree is 1 pi radian. Okay, so now my dear, what it means, this imply 1 degree is equal to pi by, that is pi, 1 degree. Here if I keep 180, na? So if I keep 1 degree, then what will happen? This will be pi here, this will be 180, this become pi by 180 radian. Take care of this concept, and if you are knowing, it is beautiful. If 180 degree is 1 pi radian, so 1 degree is equal to pi by 180 radian. So simple. So now, how much is 30 degree? So 30 degree will be, 1 degree is pi by 180. So 30 degree will be 30 into pi by 180 radian. That is, my dear, this answer will be pi by 6 radian. How much will be 60 degree? 60 degree will be 60 into pi by 180 radian. That is equal to pi by 3 radian. How much is 90 degree? 90 degree is 90 into pi by 180 radian. That is equal to pi by 2 radian. How much is 360 degree? 360 degree is 360 into pi by 180 radian. That is equal to 2 pi radian. So these are the example I have given, my dear, so that you all should know how we convert degree in radian, because in physics we never do any numerical by keeping the angle unit as degree. By keeping the unit angle as degree, we convert that degree in radian, and that way, my dear, we are doing the numericals. Similarly, if anybody will ask me that how much will be 45 degree, so that will be nothing but 45 into pi by 180 radian, and the answer of that will be pi by 4 radian. So students should aware that 90 degrees pi by 2, 60 degrees pi by 3, 30 degrees pi by 6, 45 degrees pi by 4. Orally you should know. So this is all about, my dear, plane angle. Now I will give you the concept of solid angle. Please you write something from all whatever things I have written from the board, and then I will give you a knowledge about solid angle. Well, my dear, now let's begin with the second supplementary quantity, that is solid angle. That is, you can say angle in solid. Please, angle in solid, and I'll tell you a little brief about it. My dear, the earlier was plane angle, that is angle in a circular plane we have taken. Angle in a circular plane. You can see by drawing arc. We joined so many arc, length of an arc, joining and forming angle. Total maximum angle will be 2 pi only, 360 in plane angle, right? Now here, my dear, when I talk about solid angle, it is denoted by d omega. This symbol you can see here, this is called omega, and this is d, so we call it as d omega. Again, here d is a concept for small solid angle. As I said in my plane angle topic, in physics we are describing or we are studying small angle. So we are having a concept of d theta, d omega, like that. Okay. So now it is denoted by d omega, and my dear, what actually it is 3D angle. It is 3D angle, my dear. So when I go for 3 dimensions pictures, we get this kind of a concept of solid angle. So it is a 3D angle, my dear. First of all, that's very important. And second, I'll tell you, whenever you will draw this diagram for solid angle, you will find a shape of cone like this. This is a cone I have taken, my dear. And here you can see this is a cone, and here is the inside, here over here inside, there is a solid angle. So where this solid angle is forming, at the vertex. This is called vertex. So at the vertex of the cone, the solid angle you are getting. And who described this? This much area you can see. You can see this much area intercepted and it form angle here, right, at the vertex of the cone. So my dear, sometimes we write the, I'll explain this way in a proper way. It is a 3D angle, right, formed by cone at its vertex. Or I can say it can be apex. So now look at this diagram. I am drawing many diagram here. I can draw like this. Like this is the vertex. Say it is O. Or apex you can say. I can draw this also like this. And here I can draw the vertex. And my dear, here it is the angle form. You can see this is the angle you can see. And it is called solid angle. Here is the angle formed at the vertex of the cone, and this is your solid angle. I can draw the same thing over here also. Say I have taken some body here. And here is the the apex of this body, this surface, and say I have cut this much surface. Say I have interrupted this much area, intercepted. We say intercepted. So of course it form an angle here. And this is your solid angle. Here. And this area which is intercepted, my dear, this area, itna bada tha surface. And I intercepted only this much area. And this area is called, denoted by dA. Area is A. Since angle is small, we have a concept of small angle we are studying. So I have taken small area intercepted. Similarly, here also, my dear, this is the area intercepted. You can say this is dA. Similarly, here also this is area intercepted. This is dA. So whenever you are studying the concept of solid angle, you can see the three figure. You have a structure of cone, my dear. And therefore we say it is a 3D angle. You can see here, there is an angle, here is an angle, my dear, here is the angle. The similar example you can observe when you go to the Bhelpuri shop, or when you go to the Mungfali and you talk for parcel of that Mungfali. What that shop people are doing, they are taking paper wrapper and they are folding it like this. What they are doing, जितना ज़्यादा वो fold कर रहे उतना ज़्यादा area intercept हो रहा है. Are you getting me? So my dear, again when they will, entire packet is look like a cone. The entire wrapper looks like a cone, and the angle is formed here inside. That's a 3D angle which is formed by the cone at its vertex. But this angle, this solid angle, बनाया किसने? हुआ कैसे? Because if I increase this area, of course the angle will increase. If I decrease the area, angle will decrease. So look at it, you can see. You can see. You can compare. What happened in both the situation? Here intercepted area is this much. So solid angle is also, I hope if I compare this diagram and this diagram, sir, intercepted area is more, solid angle is more as compared to this diagram, because here intercepted area is less. So my dear, how we define solid angle? How we define solid angle? So it is defined, I said, it is a 3D angle formed by a cone at its vertex, or we can write apex. This is apex. Or vertex also you can say. Am I clear? But my dear, I understood this is the angle formed at the vertex or formed at the apex. That is okay. But who made this angle? Who made this angle? How this angle is described at the apex? Who described this angle? My dear, this area, the intercepted area, or you can say area intercepted. So how we write this? This is what the definition is. Solid angle is actually d omega, which is having a definition dA divided by, and this is the radius, my dear. Again, here is a radius, because this I can take it as a radius. So what is the formula? This is dA divided by r square. So how we define the solid angle? It is formed by, or it is formed, instead of that you can say it is defined as the ratio of intercepted area that is dA, intercepted area dA, and this is intercepted area of what? Of a spherical surface. You can see this all is a spherical surface, my dear. It is so long surface, but I have taken only this much area of this surface, of this spherical surface. So here it is defined as the ratio of intercepted area dA of the of spherical surface to the, this is to the, because here I have written ratio. So previous topic I have told you ratio, then numerator. What is numerator? Area. So of intercepted area. Here the area is this much. If I have taken long area, so the angle will be this will be over here. So that can be formed. So this is intercepted area dA of spherical surface to the square of radius. To the square of radius. And where it formed, it described about apex, say O as a center, क्या बोला इसका क्या मतलब सर? इट इज अ रेशियो ऑफ इंटरसेप्टेड एरिया. कितना एरिया इंटरसेप्ट होगा? किसका एरिया? ऑफ द स्फेरिकल सरफेस. Am I clear? To the square of radius, it and to the square of radius, and where it formed, it described about apex, say O. I have given the name O. You can take any alphabet. So say O as a center. I hope it is clear. So my dear, purely the solid angle, and I'll give you one more examples. Take a potato, right? And you drill the potato, drilled. right? Form a cavity. See, when you are intercepting, how much area you are drilling, right? That much angle will be formed at that solid angle will be formed at the center of that potato, that at point O inside it, when it form a cavity like structure. So sometime it is a kind of a cavity. You can see मैंने इतने surface को drill किया ऐसे 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 करके, and then it is formed a cone type structure, you can see, and therefore we say it is a 3D angle, and it is measured by this formula. So whenever we have to calculate solid angle, we require two things. We require कितना area intercept हुआ, how much area is intercepted, divide by the distance, square of the distance from the center, and at the center this angle is formed. तो डिस्टेंस कहाँ से लेते हैं? जहाँ पे एंगल फॉर्म हुआ है, जहाँ से एरिया इंटरसेप्ट हुआ है, मतलब स्फेरिकल सरफेस से लेके एंगल जहाँ तक फॉर्म हुआ है, दैट डिस्टेंस वी टेक. आई होप इट इज क्लियर. एंड नाउ लास्ट इज व्हाट इज द यूनिट. Now unit of solid angle is, my dear, steradian. For plane angle it is just radian, but here it is steradian, and the symbol is SR, small s, small r. I told you in my rules of writing symbol, this is not the name of scientist, so the symbol for steradian is small s, small r, SR. I hope it is clear, my dear. So this is all about solid angle. So this way I have concluded the two topics under two physical quantity under a supplementary quantities. They were plane angle and solid angle. Now my dear, it's my request you make a notes of all this, because this is very important with the exam point of view. And if you have any doubt, you please inquire the doubts of yours on my email or on my WhatsApp. I am getting a lot of email, lot of WhatsApp. Students keep inquiring with me. Thanks a lot to you all. My dear, my request is that don't simply sit at home. Take a rest. Take complete rest. But simultaneously do your studies also. Because as soon as your school will start, we will be back with the examinations. So please be prepared yourself. Thank you all. Jai Hind you all.